Good morning, everyone. Welcome from New Zealand by myself, Darren and Pip. We're going to be giving a presentation or demonstration as well on automated video editing with FME. And yeah, we've got a couple of bonus tools there to show as well. Bit of an introduction. So, yep, as I said, my name is Darren Fergus. I've been in New Zealand now 13 years. And if there's any doubt, yes, I am Scottish. In fact, I never used to be in the data integration world, and I never used to have anything to do with FME or GIS. I went back to university probably about 10, 11 years ago now, geology, GIS. Never looked back since. I'm an FME certified professional in both desktop, server, and also a trainer. And familiar with Esri Stark, ArcGIS Pro, ArcGIS Online, etc., etc. Done some City Engine, procedural modeling, custom scripts, and also did some work with Blender, creating some kind of more lively, real-looking animations using Blender, which is kind of cool. And look, I also run a company called ExtremeX. It's an experience-based company based in Wellington. We operate some pretty cool high-end cars, McLaren, Lamborghini, and we got a Captain America-themed Mustang. But the real cool thing about it is it relates to what we're going to talk about today with video editing, because that's definitely a problem in the business that I want to be able to solve. But more importantly, the underlying booking system has been custom built by myself and is powered by Safe Software, the Safe Software platform, who kindly sponsor me to be able to use their software, which is kind of awesome. Yeah, and today we've got Pip Norris with myself to help go through this demonstration. Pip, if you just want to give everybody a quick introduction, please.
Hiya, I'm Pip. I'm a Kiwi based in Auckland. But a quick background, I've studied geology and geography, and I've been at Locust almost a year. Prior to that, I worked in local government and at Auckland Airport.
Cool, and you're a big lover of FME, right?
Sure.
So much fun, yay, go FME. Okay, that's a bit cheesy, but anyway. So Locust is a platinum reseller for Safe Software. We've got a great relationship with Safe, and we leverage that quite often because they give us support and they help us understand what's coming in the future. But anyway, we provide consultancy, training, licensing, and really we you know, all the solutions that we provide are everything FME basically. Okay, the business was founded by John Arnerick back in 2008. He's a chartered accountant by trade, but since then we've expanded year on year. We've gone from New Zealand to Australia. We're present in a couple of other countries as well. Ruby Donaldson is the director of Australia, and actually I would normally be split kind of 50-50 between New Zealand and Australia, but that's kind of changed a little bit with COVID. Anyway, so we've got 9+ technical experts that are certified within Locust, and yeah, that's pretty much us. Exciting company. So for today, to set the scene for the agenda, we're going to cover off video editing with FME and machine learning, because we need to be able to use machine learning to be able to do what we're going to do. We're going to look at what's the problem we're trying to solve, how can FME help, you know, what kind of transformers going to be using, you know, what's the logic, what's the iterative development behind that, and a live demo really showing that process of taking conceptually around what we're going to do to edit the video, how we relate that into the workspace and the functionality. And then after that, we're going to look at what other use cases could we use this type of integrated technology leveraging FME, and why might that be useful. And then we're going to look at, if you know, just real short, we're going to look at some other cool little tools. I love the system caller, all the different things you can do with it, especially when it comes from automated testing and automation configuration and deployment, especially when it relates to AWS. So we're going to look at some cool tools there. All right, so what's the problem? In summary, basically, I used to running ExtremeX, we used to capture videos, and there's a lot of time that takes to edit videos. For example, you know, which customer clip relates to which customer's experience. You know, it's painful to work that out sometimes because the derived generic file names that come from the camera generic system, you know, you'd have date, time, and then the front-facing, back-facing camera, but there was no, it didn't link to the actual customer until you had to pull that all in, try and relate that information. So that took a bit of time. And of course, once you've done that, you know, you've identified the customers with inside the video. Usually it was a visual check, and then you bring them into some editing software. It takes time to load the videos in, and it would take time to identify the specific locations within the video that you wanted to clip out, because we're not going to supply 15 minutes worth of ride, because you just want the fun parts, the acceleration, the pops and bangs going through the tunnel, and some of the other bits of fun that we have on the road. And then, of course, once you've done all that, you've got to be able to process those edited clips into one seamless video. And usually we take a 15-minute video, clip it into 2-minute video. And yeah, look, it's just slow. It took up a lot of time. And I spent a lot of time over the last couple of years trying to think, you know, what are other solutions could we maybe use, especially having the ability and access to the real uniqueness of FME. So option number one, we've got a camera fitted with GPS capability. If it had geofence functionality, we could set up a geofence that would trigger the camera to only operate based on specific segments of route. That would be great. Obviously, you could do that manually, but when you're concentrating on driving, you don't want to be tapping things, just in case some of you might be thinking that. Then the second option is, just on the first option. So really, there's no camera out there that has that functionality that I could find, unless it's a security camera. And that camera would only work if you're coming into your geofence based on your house location, right? So it didn't work in the sense of what I required it to do. And then there's perhaps camera fit with GPS capability, and maybe we used FME editing to extract those GPS points and then supply that to some geometry based on spatial location of where we want to edit out those specific slots. We've got a start time, end time, and then we edit the videos that way. But in this instance, we've got one less than that again, because actually we didn't have GPS enabled on the camera that we have. So a camera plus no GPS. We've got front-facing camera, and we've also got inside. Maybe we could do something really cool using FME editing, recognition service using visual cues to identify location, and then use some open source editing software to be able to extract those videos. So thinking about that, what types of transformers might we want to use to help us solve this problem? So FME transformers are going to use the system caller. I mentioned that earlier on, some really cool stuff. Honestly, system caller is really an incredible thing, actually. But we're going to use FMMPEG, and we're going to use the system caller to be able to initiate specific transactions on there, or specific functionality. We're going to need recognition connectors, so you're going to need to have an AWS account for this and registered for the AWS recognition service, spelled with a K, just so you know. We need to use the HTTP caller. We're going to send a request to Google Calendar. Remember what I said earlier on? So FME is integrated. It provides the booking system for ExtremeX. Therefore, every event is in a calendar. So if we could get the times from the calendar, if we could get the times to the videos, we could send that to the calendar, work out the name. That makes it easier to be able to work out whose video is what. So when we edit, we know who we can supply it to, and group them together as well, which is quite important. And then there's other FME smarts there that we obviously apply to that logic. All right, so yeah, the live demo now, we're gonna pass over to Pip. But just before we do, I just want to set the scene of just kind of breaking up those video components again, so it's nice and clear for everybody. So number one, all the videos that we capture on a 15-minute route, right? And we do this through the day. Usually there's a 15-minute interval between one ride and the next. The video clips are captured in three-minute intervals, so we need to be able to identify groups of videos that relate to a specific customer. We want to work out how long the rides are, how many videos are associated with that. We want to be able to then extract the start time of the video. Why do we need that? Because when the camera's recording just parked up, we don't really care about that. We want to be able to, if you think about a 15-minute ride, it's usually depending on traffic, but most part, it's like we know exactly the breakdown of that route. So that 15-minute ride, in 3 minutes, we expect to be on ramp number 1. In another 2 minutes, on ramp number 2. Another 5 minutes, we expect to be going under the tunnel, and so on. So if we find the exact start time where we're actually driving on the road, and that's where we're going to use the recognition service, it will allow us to set the cut scenes for everything thereon after. But I'll let Pip talk to that. All right, so Pip, yeah, without further ado, I'm going to pass over to you, and if you can show us, break down the individual components of the workspace for everybody, and then we can do a test run and we can show everybody what the result is. Yep, I'm just going to make you presenter. 2 seconds.
Sure, thanks, Dan.
Here we go. I'm just going to mute myself, Pip. All right.
All good. Right, so here's our workspace. Kick it off. We need to locate the files. Done that using a path reader. Tested on whether they're MP4s. And
Right, Pip, just 1 second, Pip. I just paused you on that. I think you made me presenter again. 1 second, I'll just send this back to you. I'm not sure what happened there. 1 second. Make presenter. There we go. Yeah.
That good?
Phew, I got worried there for a minute. Thought you were trying to make me present all that. No, I'm just joking. When you're ready, Pip.
Cool. So here's the workspace. Pretty much, first things first, we need to find the videos, read them in using the path reader, test for the MP4s, and then generate reports to get the video length and the video names, just so we can put it through Google Calendar and get it sorted by event. To do that, it generates a text report through the command line with the FFmpeg, which we then associate the reports back to the videos. Creating the query to go through Google Calendar, make sure it's all part of the event, groups them all together, and it assigns all the information by extracting the JSON and processing it to get that event information. We then have 2 parts to the process, or branches off. One section, it's creating a list of the videos from each event broken down by the direction of the video. So you've got the road or in the cab. The other one sorts out the first video to get the start time and aggregates that to keep one video, which we can then run through the image recognition service. So we chose to do that with just the first initial video to keep the number of frames per second down, which generate through the system caller with FFmpeg. And then we read that through, or read them back in, assign a number for the order that the images sit, and then put them through the recognition connector, to which we search for the location that the ride time starts. We bring that back through to get the date and time. So each images has a timestamp on the image, which is different to the video length as it's in the local time rather than the duration. We use that to get the first cut time in the video. So bit of a time difference calculation to get the difference between the start time and the time that the image was picked up with the location of interest. We then pop that back through Path Reader and filter out the videos based on whether they're road facing or inside facing, which we have to just regenerate as everything reads back in. The videos then need to be concatenated so they're all in one long video, which makes it easier for chopping it back up, pulling out the experience part of the ride. Easily done just with command caller, and then with that the start time's loaded through another command, splits up the video based on the time which we calculated the start time, and then the assumption that the first acceleration starts a minute beyond that. That writes out a list of videos that have been split up, which they come back through and concatenate to make a single short video.
Thanks a lot, Pip. That was awesome. I guess before we kind of move, well, 2 things. Number 1, if you could just run that process, so we've got something to show everybody. Then we can show them the video that's been edited using FME. And I guess number 2 is, what do you think was one of the hardest things to do as part of that process, Pip? What do you think was difficult?
Probably trying to work out some of the time calculations.
Yeah, totally. Yeah. Yeah, I guess it's that whole understanding the chronology of the videos, and because they're all separate videos first, bringing them together, and I guess the date time as well, right? Converting that into video time, and all the conversions associated with that. Yeah, that was a tough one, eh? All right, cool. So we'll leave you run that. We'll just cover off the rest of the stuff, and we'll come back to you, Pip. So just stand by. So we're to talk about use cases for this. Well, I think that a good place to start is the one that we've just shown. I think the power of FME to allow you to be able to do things you wouldn't otherwise be able to do based on the limitations of whatever. So if we look at this, we utilized FME to be able to repurpose videos that don't have any GPS. So being able to connect up to a calendar and extract time and link those together to allow us to generate event information, and then being able to extract images from the video to work out some start location within the video based on the recognition service and a marker in time and in space. It allowed us to be able to do what we did. So linking up an event from a calendar, grouping those categories together by name, and generating an experience-based video that allows us to just have that 2-minute clip of that 15-minute video is kind of cool. And it actually saves me a whole lot of editing time. And that's one of the reasons I haven't done it. I haven't edited a video for probably over 1.5 years now, just because it took up a lot of time. So being able to have FME now, where we can capture all those videos from those specific events, chuck them into a folder, and FME will go off and do its thing and edit all these videos out, and I can just easily then supply that to the correct customer because it's identified that from the calendar information. So that's pretty cool. So the result, we've got a video just showing the highlights of the experience, which is pretty much what you want. All right. Anyway, scenario 2, well, I guess if you look at what my company is, it's a transport company in the sense we have to be complied for the road. But if we look at other transport companies, could be taxi services, it could be companies that transport different goods throughout New Zealand or elsewhere in the world. Similar type of thing, if they've got camera systems but they don't have GPS, even if they did have GPS, obviously that would offer another use case within FME to be able to edit. But again, working on the basis of just having the bare minimum, you've got a video, no GPS, they could use things like road assets across the road, signs for specific locations as marker to create locations that could be used to extract specific components of video. I mean, it could be, when transport companies go along a specific road, perhaps as high-risk areas, and they want to do check on their drivers for those specific areas, and they can just capture all the footage, process that through, use the recognition service to pull out just those specific locations, clip the images, and then they can watch that footage as opposed to watching it all from start to finish. And trying to find that location is the biggest problem, right? So again, yeah, similar sort of thing. At the end of it, we'd have video clips that are extracted from probably a whole host of different clips based on using FME and its ability to use the system caller and other services like the recognition service. And then scenario 3, I really like scenario 3, and this is something I could probably play with in my mind a little bit, looking and thinking about emergency services, police, fire, ambulance, etc. The ability to be able to use some kind of clever video extraction would be probably highly utilized by those types of organizations. So if you think, there's some form of incident, could be any one of the 3 mentioned above, where, law enforcement need to acquire security footage from different businesses based on that location, of course, time of the event, and also from the members of the public. So if you could receive all those different types of videos from all those different types of people and entities, and have a process in place like utilizing FME, where it can go in with the event details, find the time within the video, edit out, like a 5-minute buffer or a 10-minute, just depends on the incident, right? Was it a 5-minute incident, 10-minute incident, buffer on each side? You can see how that process would go, clip out whatever the required is, and do that in an automated fashion. And then you could just have your officers sit down or whoever and review those clips of that video. And you know, that would obviously provide a more efficient ability to be able to you know, take action on whatever had actually taken place. So yeah, reported incident, you know, you got a time event, utilizing other footage that's available from the public or businesses, process that automatically with maybe some kind of buffer either side, and extract specifically event-based clipped videos that are ready for review. So that's kind of cool. That would be a good one to do, eh? Anyway, so moving on to bonus round, we'll have a look at the McLaren flying off to 102.8 seconds shortly. But bonus round, I talked earlier on about the use of system caller. The system caller really is just like a fantastic little transform. It allows you to do a whole host of things. I've kind of done a presentation on this before. We've talked about I deploy AWS, especially from a training perspective or presentations. I really enjoy using AWS because I can configure everything up. It goes nice and smoothly. A lot of you know, time it takes to make sure you put your content together and make sure it works properly. And a good way to do that is, you know, AWS machines. You can make it consistent. You don't have to worry about drivers and all those different types of things going wrong, because you've just got a nice sterile environment that's nice and clean and ready to go. But anyway, it's part of you know, setting up AWS machines, whether that be for training or presentation purposes, you know, yeah, either without thinking about generating a clone of an AWS machine, so something that's already configured up, so making the assumption that we're starting from scratch, or reinstalling FME server, whatever it might be. There's a whole host of tools that you can actually create, which I've also created, that make my life much easier. So just to cover off a couple of these, you know, generate and use host file. Why might we do that? Well, when we have an AWS machine, or it could be an Azure machine. Usually what happens if you don't assign elastic IP, you shut those machines down, you relaunch them, and the IP address changes. What happens if the IP address changes? Well, that's a problem because the host file hasn't changed, and therefore our local host now will no longer access our FME server. But that's cool. So we can run a generate new host file workspace that will allow us to overcome this issue. What I used to do in the past, if I had a lot of people on training for FME server, you can only assign yourself 6 elastic IPs, which they're static, so they stay the same, and the other 4 I wouldn't have enough. So that would mean I'd have to get around that process. So either they just don't turn off the machines. As you know, sometimes people have a habit of just turning off the machine, which is probably a good requirement depending on where you're working. However, that being said, what is a workaround? Well, we could have the generate new host file set to trigger upon a new user logging in and/or you know, they're connecting up to that machine or rebooting from that machine first time, and it will update the host file so they can access server. Well, I'll just give you I'm just going to show you those workspaces, just kind of sitting inside and how they work. Firewall configuration. This is a massive one for FME server deployment. Configuration of your firewall is a big thing, right? Why? Because, you know, you need your ports 80 open or 8080 depending on how you're deploying that. For WebSockets, so your topics, notifications, etc. You need 7078 open. And if these ports aren't open, FME server is not going to work correctly. You're going to spend a lot of time trying to work out why something's not working. For example, if you haven't got port 465 open SMTP, your email's not going to work. It's going to look like it's working, but it's not, and it's because it can't send it through the port. So again, looking at these tools is a way to you know, ensure your deployment's correct, check the configuration beforehand, perhaps even to make sure, you know, if you're doing an upgrade of these things, how is it configured at the moment? Let's log and capture that information to make the deployment more robust moving forward. So remove the chances of things going wrong because we've done all those checks first. And again, these tools help you do that. So set AWS time to New Zealand time. That's just a real quick one, right? So it's just every virtual machine you deploy. If you haven't configured it startup, it won't be configured to the correct time. It's just a little script, just runs. And again, it's just trying to reiterate that process of being able to use the system caller to spit out commands into the command prompt that will allow you to be able to do some system action and not have to remember all the codes. That's the thing, not be able to remember all the codes. That makes it easier. And then lastly, I'm not actually going to show you this one, but this is something that's a bit of a work in progress, and that's the ability to be able to configure up FME server automatically using a workspace. So that's going to be generating your token, updating all the XML files that are associated with that, and editing the lines of those files so that the HTTPS configuration for your FME server will work correctly. And yeah, that's just a bit of work in progress at the moment. We've got probably 3/4 of the functionality working there, but there's a couple of things we've got to finish off. But anyway, yeah, so let's just show you a couple of these and how they work. So I'm just going to escape out of this. I've already got the workspaces open. So if we look at this one first, generate new host file. It's real simple. What it's going to do is creators, kind of like an initiator. We're going to run a system caller. Let's have a look at what we're running. So what this is going to say is going to run ipconfig. It's going to write that to ipconfig result.txt. And what that does is that means that we can access that text file that has the IP configuration. So it will give us the IP address for that specific machine. And then we're going to take that information and replace the host file with all the correct information that we need. So we're going to update that. So basically, we're going in there, we're pulling out the IPv4, which is the IP address, we're going to replace and clean it up. And then we're going to template up the file that we want. So if we just have a look in here, this is us templating up the host file, and we're just going to overwrite the one that's actually there. So real easy peasy, simple workspace, again using system caller, making your life much easier. And then let's have a look at a couple of other ones that we've got here. This one is probably good when you start first time round. You're deploying FME server and you want to just configure all the ports from start just to make sure they're all set properly. So new machine, deploying FME server, and you want to open up all the ports that you need. You would just run this, or you could use quick, you could use the, oh goodness, what's it called? What's it called? You could use the quick translator. That's the word I was using for. Gosh, blank. You could use the quick translator for that. And if you look here, you've got, here's the user parameters, add or delete. So this is the function we're doing for all these. If we add, we're going to add in all these ports. This one we're adding port 80. We're not going to pat 8080. You'd either do it one or the other. SMTP 25. No, we're not. And it's got a bit of description around what they are. You know, your Gmail, Outlook, etc. And your important one at the bottom here is WebSocket 7078, which is useful. And we will run that, and then what I'll go and do is I'll go and run this process here. Actually, sorry, one sec. We probably just want to look at one of these. So all the open ports will be processed individually by their value. So let's have a look at an add one. Here we go. This is what it does. So it's going to run this request here. See, I'm going to run CMD. That's actually, you need that because you need to be able to run this under administrator. So you actually need a shortcut to run first, a command prompt shortcut to run first. And then we're going to run this command net shush add firewall add rule name. This is a rule name, and then it's going to open up that port. So we run that, all the ports are open. And then once we've done that, we can go and do a test, right? We can go and see what ports we've actually got open. So if we go into the next one, 1 second, open ports check. So let's just run this workspace. Now we could use this workspace before, if we're doing an upgrade to server and we want to check how everything's configured now, just in case we're messing around with stuff, we can see all the ports are open. Perhaps there's new functionality you need to use, adding in another email, and you need to open up a different port for that, and so on. You could run this and see what the status quo is. So we just write now HTML document right now, which comes up on this screen. So I'm going to bring this over. Here's all open reports. Let's have a look, see what's open on this machine. Okay, I'll bring this over here. So you see, we've actually only got port 80 open on this, and that's actually because I don't use server on this machine. But I tell you what, if we want to prove that this is working, we could go back in here and rerun that other one. So if we go into here, let's go and open up a few other things. We don't want to add port 80 because that's already added. Yeah, let's add some of these other ones. Let's run this. And yep, want to do that. Here we go. Yep, don't know why it's asking me to prompt for that. Probably because I've not run on this machine before. Yes, I'm letting you do that. Here we go. So the reason it's doing that, I think it's because it's not got that little short link here. I think that's why it's doing that here. Anyway, right, so there we go. We've opened that up now. So let's go and run the other one again. Let's go and run that report. So we go into here. Let's rerun that firewall report. See what it says. And hopefully, if all going well, we should have. It comes up here. Ah, look at that. Here we go. Fantastic. There we go. So we've opened up all those extra ports. It makes it so much easier to be able to do. All right. Anyway, so that's an example of the AWS tools. Like I said, I'm not going to go into the HTTPS one, but it's something I think will make things easier from a deployment perspective, especially setting that up. And that's a really cool thing, you know, being able to use FME as support tools for deployment and making sure they're part of a process to ensure that things don't go wrong in the future. Right, anyway, now that that bonus stuff's out the way, let's get to the real exciting thing of the day. Pip, are you there? Are you still, you haven't fallen asleep now, have you, on me? How are we looking for that video? Have we got it extracted?
Not fallen asleep, and yes, it's good to go.
That's all right. Okay, 1 second. I'm gonna make you presenter, right? And then we're gonna have a look at this. Gosh, this is where it takes me a moment. How do we do this again? Here we go. Make presenter. Here you go, Pep. Right, it's all yours.
Right, so you can see we've got all the videos, the concatenated one complete, and here's a little short one. Apologies.
By the way, guys, I love doing this. This is a lot of fun, right? Like, you probably don't capture the sound on this, but when you're out here engaged with the customer, they're laughing, they're giggling. It is a lot of fun. Coming on to the first on-ramp, we're about to accelerate up to 100. Cool. And there we go. It's automatically clipped out to the next section now. So this is where what we're doing is we're hitting all the on-ramps, we're accelerating up to 100. You can hear us laughing because we're just like, yeah, it's good. And look, I've done over 1,300 rides now, or maybe 1,200 rides now, getting close to 1,300, and this never gets old. Anyway, so thank you very much for coming to our presentation. Really appreciate you coming to check out what we've put together for you, and hopefully you like what you've seen. And if you've got any questions, we'll be on questions answers after the presentation. And big thanks to Pip for helping support us put this together for you. Okay, yeah, we'll see you soon in questions and answers. Thanks, guys. Bye.
Hello, and welcome to my presentation from the FME World Fair 2021. Today, I'm going to talk to you how the University of Turin uses FME to validate and integrate real estate data. Let me to introduce myself. I'm Andrea from Genesis GI. My company is located in Italy. I'm a project manager and FME server technology expert. As a technology enthusiast, FME is the fun side of my work because it allows me to interact with a lot of interesting things such as cloud, API, container, IoT, and so on. What I'm going to cover today: a short introduction about the University of Turin and OpenCP real estate management system. You may ask, what is OpenCP? Don't worry, I'm here to answer this question. And then I'm talk about what were our objectives and challenges and how FME helped us to solve this problem and achieve our goals. And at the end, I'd like to leave you with my conclusion, and of course, I'm here to answer to your questions. The University of Turin is one of the most ancient and prestigious Italian universities, and one one of the largest, with more than 100 buildings in Turin and in other key places in Piedmont. OpenCP is the real estate management system developed by Genesis GI for the University of Turin. The scope of this project is to help the back office to share, to maintain, update, and to share the floor plans and related data across multiple departments and different users. As I said at the beginning, FME is the fun side of my work, so I can say FME is like my guitar, it's fun to play it. Let me to describe the objectives of this project. We have to validate, transform, and load data into OpenCP. We have to enrich data to make it more useful. We have to write out different output in different format. All these things using easy procedures to help the back office to focusing on its core business. And the solution is to take a huge number of floor plans. I'm speaking about DWG files that are not so easy to share to different types of users. Let FME does their work, and here it is. We have smart floor plans on the web. The solution is one workspace hosted on FME Cloud and called by OpenCP via an HTTP calls, as we can see in the following slides. Why FME? We have chosen FME because we need a tool that helps us to maintain, update over the year and according to the customer needs our procedure. And we want to do that with less effort as possible. We need a tool that helps us to simplify the data validation process. And we don't want to care about the DWG version used by the users. A tool that uses REST API for integration. This is my preferred one because this is a very useful and easy way to interact with FME server via HTTP protocols, and a tool that is easy to deploy like FME Cloud. Let's move on the OpenCP application tier. As you can see, we have different layers: database layer, application layer, and presentation layer with different components. We have the database, the application server, map server, and browsers. And as you can see inside the green circle, we have FME server as integration layer. Users design and update the floor plans with AutoCAD and then upload through OpenCP the DWG file into FME server. Here is where OpenCP makes the HTTP calls to FME server and wait until the job is done. When the job is completed, FME server sends back to OpenCP a JSON notification. This process is completely transparent for the user. They have only to upload their DWG file and then in less than a minute can browse their floor plans on a web browser. Let me to describe the main FME workspace step by showing to you this schema. And in the next slide, I'll describe better some of these steps. But for now, start from the job submission from OpenCP, and the first step of the FME workspace is to take the file from S3 and start with the string and topology validation. If some errors are found by the procedures, one DWG file and one CSV files are sent back to the users for fix the errors and for send again the files for the validation. If no error are found, the procedures go ahead, and the next step is to check if the data are already in the database or if the data are new. In that case, the procedures go ahead and write some output. If the data are already present in the database, the next step is change detection to detect change between new and existing features. At the end of the procedures, all output are write out and uploaded on S3, and a JSON notification is sent back to OpenCP. I'd like to explain better some workspace key points. Each room has a code. Each room is identified by a code, and we check that this code follows the naming rules with string searcher and string length calculator transformers. Then, as we know, these code are a point geometry type, and with a point on area over layer transformers, we check that these points are not duplicated, are not outside the room area, and there is only one code inside each room. Another key point is the topology validation on area with area on area over layer and clipper transformers. We have to check if room area are not overlapped with other room area, or if room area fall outside the perimeter of the floor plans. And then we, as I said before, we detect if there are changes between new and existing feature. And to do that, we use change detector transformers. The FME Workspace write out different output in different formats. For instance, we have WKT to import geometry in PostGIS. We have DGN files from Observer, and DWG and CSV files for the user validation. As I said before in the schema, we send back to the users these files to check the potential errors. And we have, of course, updated DWG files, and at the end, the PDF files for the users. So the users can download, print, and share these PDF files. In conclusion, let me to sum up my main points. Deliver real estate floor plans and related data across multiple departments and different type of user is a day-to-day activity at the University of Turin, and FME is one of the most important players in this process. The FME success key are low maintenance and easy to upgrade workflow and easy to deploy and integrate tools. Now, I'm happy to answer to any questions you might have in the following Q&A session. And thank you so much for your time, and feel free to contact me. Bye.
Hello and welcome to everyone here at FME World Fair 2021. I hope you are enjoying this wonderful World Fair, and today I'm going to take you on a journey of how FME is being used in the documentation and conservation of cultural heritage sites, especially the Chivas and Chaityas of Kathmandu Valley. I am Asis Manandar. I'm a senior consultant here at One Spatial Australia, and I'm also a member of the Chiva Chaitya organization, Kathmandu, Nepal. Today, I will start with a brief introduction about Chivas and Chaityas, what they are, why are they cultural heritage sites, what are the issues surrounding its conservation, and what was the GIS problem that we faced. I'll talk about the GIS solution and how FME has been a key part in delivering that solution. I'll also discuss about further challenges and issues that we face or our future plans. So let's begin. So what are Chivas and Chaityas? Chivas and Chaityas are beautiful Buddhist shrines established by the general public in public places in Kathmandu Valley. This culture of establishing Chivas is one of a kind in the world. These are beautiful monuments found in public roads, alleys, courtyards, private hills, everywhere in Kathmandu, in and around Kathmandu Valley. They are established as a remembrance to deceased relatives or as a respect to Buddhist philosophy. Usually, the chivas are 2 meter in height, but some of them can be about 30 centimeters or even as large as 50 meters, such as the one in the picture, which is Swambhu Mahachaitya. Chivas are usually stone carved, but sometimes we can find bricks or clay made chivas and chaityas. In terms of numbers, we expect that there are about 2,000 to 2,000 chivas spread all in and around Kathmandu Valley. So why are they archaeological heritage sites? So it is said that chivas had been established since the time of Lord Buddha. Some of the chivas found in Kathmandu Valley in public places are actually 1,500 years old. So they carry an immense archaeological value. Chivas and chaityas are worshipped daily by the people of Kathmandu, and they hold an immense cultural and religious status as well. There are many different types of chivas, and each one is unique. It is like bird watching. Once you start to admire its beauty, you'll find it fascinating to discover the various types of chivas that you can find. Chivas and chaityas hold such archaeological, cultural, and religious values that it was also listed as World Monuments Watch in the year 2020. But unfortunately, urban development, or I would say unplanned urban development in Kathmandu Valley has led to the loss of open space, and hence encroachment or even destruction of chivas has happened. So there's not a proper body which takes care of these chivas and chaityas. So we think local governments also need to protect those areas from encroachment. Lack of awareness of its importance is the main factor for its destruction, as general public either do not realize the importance or are too busy with daily life that they do not care about these valuable assets. But it is also to be noted that in many places the chivas are well preserved. So one of the technical, or I would say the main technical issue that we faced while conserving or documenting the chiva and chaityas is that we don't have reliable data. Since chivas and chaityas were established by the general public in public areas, there have never been a record of all the chivas or even most of the chivas in a single location. So so the lack of technical data has created issues such as we don't know where the chivas are, and even if it's destroyed, we don't know which ones have been destroyed. So in 2012, a group of heritage enthusiasts, my colleagues at Chiva Chaitya organization, realized the importance of Chivas and Chaityas and came together to tackle the issues surrounding its conservation. Their first plan was to document all the Chivas and Chaityas. So they started to record Chivas and Chaityas by taking photographs of them whenever they encountered while going in and around Kathmandu. They logged the details in spreadsheets, but after some time, it was quite clear that recording the Chivas in spreadsheets was not a viable solution. My colleagues were having difficulty in distinguishing which Chiva had been recorded before, and so they would double up the recordings, and after a few years, it was just not viable. They soon realized that a map was required so that they can, whenever they're in the field, they can see if that Shiva that they are standing in front of had already been surveyed or logged, documented. So we realized a map was required, and it would be best if we could generate the location data or the required for the map from existing photographs. The requirement was it had to be low cost because we were all working on as a volunteer, and it had to be very user friendly and integrated with the current workflow. So we had lots and lots of photographs, and we needed a map to create that can be used in the field. So FME was used for the processing, and because of FME, we were able to try out various softwares, various GIS softwares in a rapid development manner. We chose from a variety of software such as ArcGIS, Google My Maps, QGIS, or GIS Cloud. And later we found that if we create a map with features in which the images are an inline image embedded in the feature itself, and generate a KML file from it, we can use it in apps, in Android apps, and that would be no cost at all. We choose KML file because we could save images as an attribute itself. Other GIS file types such as shapefile, map info do not support this. And also with this solution, we do not require a separate files storage system to generate the inline images. So our solution was to collect the photos from a mobile, which had location data enabled, and that would be processed in FME, and FME would then generate and periodically update the KML file with the new photographs. The KML file would then be passed on to the users in the field, and they would load it up in their mobile phones in maps.me or Google Earth mobile app. So in this way, they could see which Shivas they had documented earlier, and start to document the ones which have not been documented. And that this would be a cycle, a continuous process, and we would update the map every about 2 to 3 weeks. So as a result of this process, a map of all recorded Shivas and Chaityas was generated. As of 20th March, we have recorded about 1,077 Shivas and Chaityas in and around Kathmandu Valley. In the image on the right, you can see the features, the chivas around Kathmandu Valley. And if you click on any of the feature, you can see the attributes, the date and time, and other values, along with an inline image. So this was very helpful, and you can see the same in a mobile app as well. So our future plans are to restore the damaged Shivas. We can identify it easily through the map as well. Till now, we have restored about 6 Shivas, and more are being restored currently. Also, we plan to have a proper and periodic inspection of all the Chivas in future. So in conclusion, I would say that FME has helped in rapidly testing and designing various output formats. Without FME, it would have been very difficult to convert images and merge it with Excel data and then create a KML file with inline images. It is without doubt that FME has helped in heritage protection. This output will be very helpful in future, as well as it will contain the records of all Chivas, which are very culturally and archaeologically important. So for more information, you can log on to chivachaitya.org.np or follow us on Facebook or Instagram as well. With that, I'd like to conclude my presentation. If you have any questions, please let me know and I'll be happy to answer them. Thank you.